Okay, we are on to lesson 7.2, which is graphs of inverse functions. And in this lesson, we have two learning targets. We want to be able to graph inverse functions and identify the symmetry. We also want to use the graphs of inverse functions to determine the domain restrictions. Well, the graph of a function and its inverse show symmetry, and it arises from the relationship between the domain and the range of the function. If you remember, the domain and the range are swapped in the inverse of a function. So let's practice that now. So we're going to look at, we've got a function f of x, and we're going to go ahead and write the inverse of it. So we'll review that from yesterday. If y equals 3x minus 2, we'll switch x and y. X equals 3y minus 2, and then we'll solve for y. So we'll add 2. X plus 2 equals 3y, and then we'll divide by 3. So y equals x plus 2 over 3, which is really f inverse. And I'm going to write it as 1/3 x plus 2/3. Write it like that. Okay, you can leave it x plus 2 over 3 if you want. So now we have a function f of x, and we have the inverse. And these are linear functions, so we'll use slope and y-intercept to graph them. So for the first function, I'm going to graph that one in blue. Okay, so I'm going to graph f of x equals 3x minus 2. So I'll start down here at -2. And then I am going to do my slope, which is 3 over 1. So I'm going to rise 3 and run 1. Rise 3, run 1. Rise 3 and 1, run 1. Or I could go down 3 and the other direction, 1 as well. And so there is f of x. Then I'm going to use red to graph the inverse of f of x, f inverse of x. And for this one, we are going to start at 2/3, and then we're going to have to go up 1 over 3. So 2/3 is right about there. We'll go up 1, 3. Up 1, 2, 3. Or we could go down 1, and so on. And here's now our, I'm going to do that again, make it a little neater. Down 1, 1, 2, 3, right there. And this is going to be our f inverse of x. A little easier to do on paper with a ruler. But hopefully you can see that there is specific symmetry to the graphs. The graph and its function have symmetry for a special line, a line that goes through the origin. So I'm going to do that line I'll do that line in pink. And so if you see the line y equals x, that's the identity. Every y coordinate equals every x coordinate. That means there's ordered pairs at 1, 1, and 2, 2, and 3, 3, and 4, 4, and so on. And so this becomes a symmetry line, and the f of x and f inverse of x are symmetrical to that line. So that's the line y equals x. Okay, and that's because, again, the x and the y switch places. So the domain becomes the range becomes the domain. Okay. So the graph of f of x and f inverse of x are symmetrical to the line y equals x, or what we call the identity line. Okay, so now on page 2 we have an example, and they've done that for you now. They've done the two graphs, and so we can actually fill in the tables to kind of see the relationship between the domain and the range and how they switch. So in our first graph of our function f of x, so again I'll use blue for the function f of x, which is 1/2 x plus 3, they put in an ordered pair of -4 and -2 and 0 and so on. And so that's going to be this graph right here. Okay, so when they plugged in -4, they got out a 1. And -2, we got out a 2. And so on. 0 gave us 3, that's the y-intercept. 2 gave us 4, 4 gives us 5. So when we graph it, the inverse of that function, we should see what's graphed should be the switching of the x and the y. So now the x's, the range will go in place of the x's. So we're going to put 1, 2, 3, 4, 5, and we'll see come out the domain, which it was -4, -2, 0, 2, and 4. And that's going to be this line right here. Both f of x and f inverse of x are linear functions. And so the domain for both functions would be all real numbers. Okay, that's going to be true whenever we have linear. It's when we get to the quadratics that we have to then worry about domain restrictions. Right, so we've got some try these there that we can practice. And so our first one is f of x equals -2x plus 3. And so I'm going to go ahead and switch to graph paper to graph that one. All right, so this is going to be for part A. And we've got a function, f of x equals -2x plus 3. So I'm going to start, I can start by graphing that one. So make a grid. There's my x-axis, and there's my y-axis. Okay. So I'll graph that function in blue. Okay. So start at 3, and then down 2 to the right 1, down 2 to the right 1, or up 2 to the left 1. And now there's our function, f of x. Okay. What I want to do next is graph the inverse of this function. So one of the things that I could do to graph the inverse is think about the ordered pairs that I have for this function. So this function's ordered pairs, if I think about the ordered pairs, I've got some points plotted at, I have -2. So at -2, I'm up 1, 2, 3, 4, 5, 6, 7. I'm up at 7. I have an ordered pair at -1, 2, 3, 4, -1, 5. I have an ordered pair at 0, 3. And I have an ordered pair at 1, 1. And I have an ordered pair at 2, -1. And I have one more at 3, -3. So if I want to graph the inverse of this function, I could rewrite it as an inverse and graph it, or I could just swap these ordered pairs. So f inverse of x is going to have ordered pairs of 7, -2, and 5, -1, 3, 0. 1, 1 will be the same. -1, 2, -3, 3. And so now I can graph the inverse. 2, 3, 4, 5, 6, 7, -2, and 5, -1, and 3, 0, and 1, 1. I told you that would be the same. And then -1, 2, and finally -3, 3. And this is going to be our f inverse of x. And I'll once again put the identity line in pink so you could see the symmetry. Again, it looks a little neater when you have your own paper and you have a nice ruler, but you can hopefully see symmetry now. All right, back to our lesson. We could do the same thing with part B, but we're going to move on. And we'll save some of the check your understanding for in-class work. Okay. So now we want to look at what happens when we work with the quadratic functions. And the quadratic functions are going to have domain restrictions. So we're going to want to be careful with those. And so we can still use symmetry to graph a function about the line y equals x to help you determine the inverse. So here's an example. It says graph f of x on the coordinate plane. And so they gave us f of x as the x plus 2 quantity squared. And maybe you remember that means that we're going to be graphing this one to the left 2, and then it's just a typical quadratic with this shape. Okay, so that is our that's our quadratic. If you remember, some key points on a quadratic are points like -2, 0, 0, 4, and -4, 4, because we're squaring every number we put in, we square. So when we square 2, we're going to get 4, and so on. So next we are going to graph the reflection over that line. So again, that line, that symmetry line, which is right through the origin, that's the symmetry line. If we just graph a reflection, or we just take and reverse the x's and the y's, then we will get the inverse. Okay, and so it looks like that. So that's the inverse. Some students might think an inverse of a parabola would just be an upside down parabola, but that is not right. The inverse actually switches the x and the y's. And so a reflected parabola that we see over that line is actually not a function. Okay, so the reflected parabola is not a function. If you can see, there's a couple of places where you can see that an input would have more than one output, and that's how you know. So if you were to pick any x value like 4 or 6 or 8 or 10, you can see that there's more than one output. There's a output on both sides. And so we do not have a function. And so that's a problem. Our inverse was not a function, whereas our original function is, our inverse is not. So what we would want to do is set up a domain restriction. And so if we think about this graph, if we maybe only graphed half of it and we reflected it, we would have a function. If we graphed only this half, we reflected it, we would get this half. Again, that would be a function, but having the whole parabola reflected does not create a function for our inverse. So we have to set up a domain restriction. And so what we could do on our original parabola is on f of x. So for f of x, if we let our x's be greater than or equal to -2. So let's say we took our x's from here forward. So just this half of the graph. Okay, that would reflect over, just this half of the graph would reflect to this half of the graph. Okay? And then we would have an inverse. So we could do that, or we could do the opposite. We could say, or let's let all our x's be less than or equal to -2. Well, then we're going to be just graphing, this half of the graph, or this half in the graph when it reflected, but just not both. Okay, so, but not both. Both would be all real numbers. So we're going to do that. And so you can see where it says graph the line y equals x. So that's our symmetry line. That's the one I usually do in pink. There's our symmetry line. And then we can see that our original function, okay, if we just graph from -2 on, looks like that. When you reflect it, switch the x and y, looks like that. Okay, so we will have to set up restrictions for some of those. Okay, well, I've saved the rest of these to practice in class with you. I think that you should be able to do some of the check your